we are going to check the comparison in between the traditional wiring of the AC panel and the new wiring of my intelligent boat, hybrid boat, depending of a solar system, generator, and shore power system. And we are going to check the main difference. The main difference in between both of them is in the inverter. And right now we are going to analyze what is the difference. The traditional inverter like this, this traditional inverter is not smart, it's not intelligent. This inverter receives DC power from the battery bank. I turn on the switch and the power enter here DC. And this element convert in AC when I turn on the switch. Convert in AC and the AC power enter here in the switch selector. Generator, shore power, or inverter. That's clear, guys? And this power enter in the AC panel. That's it. In other words, in the AC panel, in the traditional AC panel until today, I have power coming from the shore power, coming from the inverter, or coming from the generator. 3 sources of power. That's clear? But that decision depends on me, because I select this one or this one or this one. I select. This is my decision in the traditional boat until today. Everybody follow me, guys? All right. This power in the traditional boat with the old generation inverters, this power coming out from that inverter is not a perfect power. For that reason, in some boats, some years ago, you see that if you select inverter in the AC panel, only use those breakers. Don't use this, this, and this, because the inverter is not able to support this, this, and this. Only the blue ones. The people put a mark, blue or red or whatever. You understand? Because those inverters are not good with, they are good only with the small air conditioning unit, not with the big one. In other words, the capacity of the previous generation of inverter is not perfect. If you are in shore power or in generator, yes, you can use all of the breakers in the AC panel. In inverter mode, only use this, 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 and this. In other words, the inverter in the past was used in emergency. You remember, Captain? Okay. In the new technology, the situation is different. The situation is this. We have a shore power, we have a generator, we have an intelligent automatic transfer switch. That transfer switch detects if the power here is on or is this, and he switch automatically to this or this. Automatic transfer switch. And that power, the output of that automatic transfer switch, will be entering all the time in the input of the new inverter charger. The AC power coming in is coming from shore or generator. Automatically. I don't need go over there to change because I install an automatic transfer switch. Okay, but at this element, the inverter charger can work with the traditional input. The traditional input is DC, positive and negative, coming from the battery bank. The battery bank. And the battery bank will be charged from the solar panel. Okay. But how is that administration? That administration is with an intelligent bus bar positive, an intelligent negative bus bar, and with a computer, and with some data cables. This is the smart situation. Okay, let me explain how is the process to connect that in the board, and after that we return here. Good, guys? All right. Let me turn on. Follow me. In this moment, I want to connect my shore power. My shore power, and immediately the automatic transfer switch select shore power. Right. And also, I want to connect at the same time both of them. I want to connect the DC power coming from the battery bank, entering here 48 volts, positive and negative, and I want to connect here in the system. In other words, in this moment in the system, I have 2 inputs of power for that inverter. One input is DC, and other input is AC. Okay, look, the automatic transfer switch, they have input of AC, hot, neutral, and ground from the short power, input of AC, hot, neutral, and ground coming from the generator, and in the back, other output, hot, neutral, and ground coming out and entering here at the input of the inverter. Good, guys?
Yeah.
Okay, and the DC, I have 48 volts, positive, negative, 48 volts, 48 volts, 48 volts, 48 volts, negative, 48 volts, positive. I have a fuse, and I have a shunt in the bottom, the shunt. You remember what is the function of the shunt in the previous class?
So you measure amperage.
It's measure the amps proportional for the ammeter. Okay, great. All right, this one will be used to read amps in those ammeters. You see, I installed two shunts. One shunt here for this, and other shunt over there for this other meter. This one is a DOD or SCA. Is to sense the percentage in the battery bank that I have of power. If it's 100% charged or 90 or 80. Why? Because I wanted that when the level of charge in the battery bank decreased 20%,
Your generator kicks on. Right?
this computer, intelligent computer, send the signal and start the generator automatically.
Signal, right.
And the generator provide power for the inverter charger and charge the battery bank again. That's the intelligent part. Okay, good. The DC power coming from the battery bank enter in those bus bars. Negative bus bar in the bottom and positive bus bar on top. Everybody follow me? Let me turn on this. Okay. Everybody follow me, guys? Positive bus bar over there and negative bus bar over there. Why I need that positive bus bar and negative bus bar complicated, Mr.? It's not complicated. This positive bus bar and negative bus bar is intelligent positive and negative bus bar. In this system, you can administrate how much voltage and how much amps enter from the solar panel or from the charger, and how much voltage and amps DC are going out to the inverter. It's intelligent because you can administrate in those gauge the flow coming in and the flow coming out in the positive bus bar and negative bus bar. This is the DC side coming from the battery bank. Look at this. In this point, this is the negative bus bar, the yellow, and this is the positive bus bar connected with a mega fuse with the big positive bus bar. This positive and negative are coming from this MPPT. What is this? The solar controller. And the MPPT receives positive and negative from the solar panels. Okay. This is the power coming in from the solar panels. Correct, guys? And this is the power coming out for the input of the inverter charger. Because this power entering and this power going out is administrated here in the bus bars of this portion is the links distribution, and this one is the shunt because here is located the shunt, and they are connected with bolts. It's simple. It's a positive and a negative bus bar. That's it. Don't worry. And I have a connection here, a data connection. You see the data cable, guys? Yeah. A data connection with the computer, and the computer integrate here the flow of DC in and out in the display, and I can see how much voltage are flowing in and out in my batteries and my solar panel. And this is nice because I can administrate. I can say, okay, I am charging my batteries right now with 18 amps per hour or something like this, and the solar panel is only producing this because the sun is not good. I see in the display all of those flows because I have administration here. All right. Look at this, guys. In this moment, the inverter charger is working in the mode charger. What is the meaning of that? But I have power entering here through the short power line. You see? I have power, and the power is coming in, and the power is entering here, 120 volts coming from the short power. However, this element is working like a charger, charging the battery banks, because this element detects that the level of charge in the batteries is low and it's charging right now.
And it has an extra
However, it's charging, but I have power in my AC panel, and I have power here, 120 volts in my AC panel. What is the meaning of that? Not all the power entering from the shore power is used for the charger. Some portion of that power is entering directly in the panel. Everybody follow me, guys? This is the interesting part. In the previous inverter,
Never was.
no,
This is wasted.
or
Right.
is charging or is
Just off.
exactly. All right, look at this. In this moment, in my AC panel, I have only the lights connected, but I can connect the air condition. Now the air condition unit is running. You see? It's running, and I want to see how much is the consumption. Look at this. In this moment, the consumption is 420 and 56 watts. The consumption in the AC panel. And this is the configuration in this moment. I am receiving 1.5 kilowatts from the shore power entering here in the inverter charger, and the inverter charger is charging the battery bank. It's charging with the 18.2 amps per hour. You see, the battery charger is receiving nothing from the solar because we don't have sun in this moment, and I have off the switch of the solar panel. It's receiving nothing, and the MPPT is not sending power here. That's clear? Yeah. In this moment, the power entering from the shore power enter in the inverter charger. One portion of that power is used to supply power for the AC panel, and the other portion of power is charging the battery bank. Pay attention. I am going to disconnect the shore power because the shore power is off. Can you disconnect the shore power, please?
Pull it here.
Yeah. Okay. And now, immediately, it passed from charger to inverter. And you see, right now, I don't have power coming in from the shore power. The inverter is producing power, is producing AC power here because it's suctioning power from the batteries.
Right.
Ah, I can
Cool. Shows you
administer
the
it.
flow
minus
too.
10 amps,
Shows
yeah.
you the flow also.
This is the flow, 10 amps, 10.5.
So that's your AC.
And I am working with air condition and lights. Guys, let me show. I don't have power coming.
What if the signals?
Look, I don't have power coming from the solar panel in this moment. Only from this. And this is the consumption. Look, the batteries are discharging in this moment at 10.5 amps. And the AC load, the consumption is 458 watts. And the solar panel is producing 0. This is the administrator. I know what happened.
So you got about 8 or 9 hours.
It's like an iPad. It says 15 to 30.
It can be connected with the iPad. Yeah,
yeah?
Right now
because they have a here connection Bluetooth with the iPad. Yes, this is the next class. I am going to explain that connection. My battery right now continue 100%, 53 volts. This is good, and I am running my boat in this moment completely with solar system. You see, with solar system. Draining the battery.
Right.
Only solar. If I connect again the shore power, let me show what happened. Look, in this moment is in inverter mode. I connect the shore power. Right now I have power here, and look at this. The system is intelligent and sense suddenly that the power enter again. Pay attention. Pay attention. Pay attention. In this moment, the power is hey. They change to charge and detect that the power is coming in.
It's good that it's not. It's